Hello everyone, welcome back to my channel. So today in this particular video we'll be talking about the oxygen hemoglobin dissociation curve, right, or which is also called as the O2HP dissociation curve. So in this particular curve what we can see is that we are having two axes, x-axis and the y-axis. On the x-axis we are talking about the partial pressure of oxygen, which is measured in millimeter of mercury. On the y-axis we shall talk about the oxygen saturation, which is measured in percentage, right. So overall, if we see the curve, it is having one particular shape, that is the S shape. So this curve is the S shaped curve, which is having two parts basically. One part is the flat upper part, which you can see this part is the probably the flat upper part. This is also called as the plateau region, and another part which we can see over here in this curve, that is the lower part, and that is quite steep. So this particular region is the steep lower part. So two parts we are having in this S-shaped curve. One is the flat upper part, that is the plateau region, and another one is the steep lower part, isn't it? Then this curve actually tells us very important things. For example, if I will take you to another slide, this particular slide here, we have talked about that this curve is having two regions, plateau region and the lower part, steep region, right? So basically this graph tells us about the affinity of hemoglobin for the oxygen. So everybody knows that if this is the RBC, and inside the RBC we are having a very important glycoprotein, that is the hemoglobin. So hemoglobin is having the inside hemoglobin, there is a iron present over there as well, right? There are the alpha chains and the beta chains, everybody knows about that. So oxygen is having the capability to bind with that hemoglobin, right? So what happens is, let's say this is the hemoglobin, right? So let's say this is the hemoglobin and oxygen binds to it, right? So we will be talking about the affinity of this hemoglobin, right? That how efficient this hemoglobin shall bind to oxygen, right? So this particular thing is actually defined by this particular graph, that is the HbO2 dissociation curve, that how efficiently the hemoglobin can bind to the oxygen, right? Or will it be able to release the oxygen at the tissue level. So what we are talking about, will come to know about it in this particular video. So guys, here two regions we have talked about, one is the plateau region and another one is the steep region, right? Now if we talk about the oxygen, right, usually we are breathing in and out. So it means at that point of time you are inhaling the oxygen and you are exhaling the carbon dioxide out. And let's say if these are the blood capillaries, right, so oxygen should go inside, so which means perfusion should happen. So perfusion of the oxygen will be happening in the pulmonary capillaries, and CO2 will be going out from the capillaries into the lungs. It is happening very frequently, right? So now let's say at this particular level, the plateau region, I am saying that we are at the lungs level, or we are at the alveoli level, and the steep region which I am talking about, let's say we are in the tissue level, we are at the tissue level, right? Now you tell me, if we are talking about the alveoli, right, so there you need more oxygen, there you will find more oxygen or more carbon dioxide, there you are finding obviously more oxygen, right? So here the O2 will be more, right? And at the tissue level, the oxygen level reduces, right? So because it is far away, because in the lungs we are getting the oxygen directly from the atmosphere, so from there, from the lungs, the oxygen has to travel to the tissues, so obviously it will be dropping. So if we talk about in the lungs, partial pressure of oxygen is almost around 100%, as you can see over here, right? So in the lungs the partial pressure of oxygen is around 100%. So probably if you talk about the saturation, this might be around 97 or 96, right? So you can see that the partial pressure of oxygen at 100 partial pressure of oxygen, right, you can see the saturation is the highest. Now from the alveoli level, if you will move towards the tissues level, right, the oxygen saturation starts dropping, but at what level? That is also important. So in the tissues, if you will see, the partial pressure of oxygen is around 40 millimeter of mercury, that is at the tissues level, and it is around 100, partial pressure of oxygen is around 100 in the lungs or at the alveoli level. So what we can see is, and can you see the saturation also? If we talk about that at 100 partial pressure of oxygen, if it is 100 at alveoli, the saturation is around 97%, right? But if you will move from the alveoli to the tissues, right, from the alveoli to the tissues, it means the oxygen is moving from the alveoli to the tissues. Your RBC, your blood is moving from the pulmonary capillaries to the tissues, right? It can be any tissue, right? So there the oxygen level starts dropping, but at what level? Even if you are talking about the tissues, that almost around, if the partial pressure of oxygen is around 40 millimeter of mercury, then also the person is actually maintaining about, so you can see this graph like this. So even at 40 millimeter of mercury, the person is having that oxygen of around 75%, right? So even if you start moving from the alveoli to the tissues, right, initially the partial pressure of oxygen will be decreasing. For example, it was 100, then it became 90, still the saturation is maintaining, right? So you are going from here to here like this, so still the saturation maintaining. You go from partial pressure of oxygen from 100 to 90, 80, 70, and then after that, if partial pressure of oxygen drops further, then the graph will be showing the desaturation. The graph will move towards the desaturation, right? So that is the thing. So take home point from this slide is that this curve is the S-shaped curve. This curve tells us about the affinity of hemoglobin with the oxygen. Second thing, plateau region and the steep region, we are having these two regions. Partial pressure at 100 partial pressure of oxygen, the person, physiologically the person's or the human is actually maintaining around 97-98% of saturation. As we move towards the tissues from the alveoli level, as we move towards the tissues, even if the partial pressure of oxygen is dropping, let's say from 100 to 90, 90 to 80, still we are maintaining high saturation level. But even if it further drops, then the desaturation starts from there, but it desaturates till around 75-70%. As we can see that even at the tissue level where the partial pressure of oxygen is around 40 millimeter of mercury, still we are maintaining around 75% of saturation. So it doesn't mean that if you are going towards the tissue level, if your RBCs are going towards the tissue level, your desaturation will be happening for around 40 or 50%. It usually doesn't happen, right? So much of desaturation is not there still at the tissue level. Now one more thing is that this graph works very beautifully, right? So you imagine that let's say that your body needs more oxygen, right? For example, you are doing some physical exercise. In that physical exercise, obviously your tissues needs more oxygen to build up more ATP. In that sense, this curve will be actually working in your body. So what will happen is that if in that time you need more amount of oxygen, this curve is having the capability to shift either towards the left side or towards the right side, right? Now because your muscles or your tissues needs more oxygen, so what do you think that how should be the affinity of hemoglobin for the oxygen? So whether this bond, if I talk about whether this bond with the hemoglobin with the oxygen, it should be loose bond or it should be very tight bond. It should be loose bond because we need to send this oxygen to the tissues, right? So hemoglobin and oxygen, if you talk about this relation, if the hemoglobin and the oxygen, if there will be a very loose tissue, I mean if there will be a very loose connection between two, okay, so this can detach very easily, and if this will detach, it can actually be transported to the tissue, it can be given to the tissues, right? So this curve is having the capability to shift either towards the right side or either towards the left side. Whenever it moves towards the right side, it will be releasing more amount of oxygen. So it will be causing unloading of oxygen to the tissues. It will be causing unloading of oxygen to the tissues at that point of time. So if your tissue, if you are doing some physical exercise, if you are doing some strenuous exercise, at that point of time your body is having the capability to release more oxygen to the tissues, isn't it? So that is the thing. Now this unloading of oxygen can happen at that point of time. So whenever you are doing any kind of physical exercise, that's how the unloading of oxygen can happen at that point of time. So what will you think? What will happen to the binding affinity of hemoglobin with the oxygen? Obviously, if your graph moves towards the right side, the binding affinity of hemoglobin will be decreasing, right? Because binding affinity, if it will be increasing, right, then how will it be able to release the oxygen? It will not be able to release the oxygen. So hemoglobin, oxygen, if they are binding very efficiently, then it will not be able to release the oxygen, right? So that is the thing. It is very simple to understand, because look, it is something like this. Then if you are holding something very tightly, you will not be able to lose away that thing, right? So somebody will not be able to take it if you are holding it very tightly. But if you are holding it very loosely, then obviously the other person will be able to take that thing. So it is as simple as that. So if your body needs more oxygen, binding affinity of the hemoglobin with the oxygen will be decreasing, and this particular S-shaped curve will be shifting towards the right side, and that's how the unloading of oxygen to the tissues can be happening, right? I hope till now you are clear, right? Then after that we shall move on to one slide which I want to show you. So this curve is illustrating the affinity of hemoglobin for the oxygen, which we have talked about. In the lungs, the partial pressure of oxygen is around 100 millimeter of mercury. At this particular partial pressure of oxygen, hemoglobin is having the highest affinity for the oxygen and is 98% saturated approximately. At the tissue level, if we talk about, we have talked that partial pressure of oxygen is around 40 millimeter of mercury, where the hemoglobin is having a lower affinity for the oxygen and releases some but not all of its oxygen. So it will be releasing some of the oxygen but not all of the oxygen. For example, hemoglobin is carrying 100 molecules of oxygen. It can deliver 70% of the oxygen and not the 100%, right? So that's what I am saying it. So even at the tissue level, oxygen, because it is not releasing all of its oxygen, 75% saturation is still maintaining. The curve is a S-shaped curve, very important, and is having a two parts. One is the flat part or the upper part, that is the plateau part, plateau region, and another one is the steep lower part. I hope there is no confusion till this point of time. Now one more thing, if we talk about the flat upper part, that is the plateau region, it is acting as a buffer, right? It is acting as a buffer in a sense that PO2 can drop to about 80 millimeter of mercury, yet the hemoglobin will be remaining highly saturated with the oxygen, which I have talked about that in the previous slide also, that even if the oxygen is 100%, even if it is dropping further, for example to 90 or 80 or 70, still the saturation is not fluctuating further, right? So even at the level of 100, 90, 80 or 70, we are maintaining the saturation in between this range only, right? So that is the thing. So that is the beauty of the plateau region or the flat upper part of this particular graph or curve, right? So even if the PO2 is dropping further from 100 to 80 or 70, still the HB is highly saturated with the oxygen. If we talk about the steep lower part, right, it is telling that if the tissue requires more oxygen, substantial amount of oxygen can be removed from hemoglobin without much further drop in PO2, right? So which we can see over here is that even from the 40, if you move towards the 30, right, okay, even from the 40, if you move towards the 30, here you can see this steepness, right? So what they are saying that if tissue requires more oxygen, substantial amount of oxygen can be removed from the hemoglobin without much further drop in PO2. So here we can see the saturation is dropping over here. For example, from 80 to 50, right? You can see saturation drop is there, but only between 30 to 40, right? So partial pressure of oxygen is not fluctuating much, but the saturation drop is there further, right? So it is like this, that initially the partial pressure of oxygen is not moving much. I mean to say is that initially, even if the partial pressure of oxygen is dropping, the saturation doesn't move. But at the later half, if you go towards tissues, right, after 80% or the 70%, saturation starts to drop. But if you go beyond 40, then what will happen is more desaturation can happen, but the partial pressure of oxygen is not moving much, right? So the case is, at the level of oxygen, the saturation levels are not dropping much. At the level of tissues, the saturation level might drop, but the partial pressure of oxygen is not moving much. Okay. Now, a change in binding affinity of hemoglobin for the oxygen shifts the oxyhemoglobin dissociation curve to either side of the normal, right? So there is a concept of P50. What is a P50? I will try to show you now. So P50 is that particular at that particular point where the partial pressure of oxygen is at which the 50% of the hemoglobin is saturated, right? So it is telling us a way to assess the binding affinity of hemoglobin for the oxygen, right? So normal P50, if we talk about, that is for the arterial blood, is around 26 to 28 millimeter of mercury, which you can see over here, that, right? If you talk about this particular point which I am highlighting right now, at this particular point you can see that it is fluctuating in between 26 to 28, right? 26 to 28, right? That is the normal range of this particular P50. So if this P50 shifts towards the right side, we say that generally this is the right shift, and if it is shift towards the left side, then we are saying that particularly this is the left shift generally, right? So that is the P50. So P50 is that particular point where the partial pressure of oxygen at which 50% of hemoglobin is saturated, right? So that is telling us about the binding affinity of hemoglobin for oxygen. So if the P50 will be higher, there will be the decrease in hemoglobin affinity for the oxygen. It is very simple. If, for example, these are the tissues, right? These are the tissues, and the oxygen delivery has to happen in the tissues. So if this is the RBC, right, in the RBC what is happening? Hemoglobin is there which is binding to oxygen. If the binding affinity is not good, if the binding affinity is loose, then only this oxygen shall be detachable. But if the HbO2 binding affinity is more, the O2 will be having problem in detaching itself from the hemoglobin, right, which I told you earlier. So hemoglobin oxygen, if the affinity will be decreasing, if the affinity of hemoglobin with the oxygen, if it will be decreasing, then obviously it can be delivered to the tissues. At the same time, if the affinity, right, will be more, then oxygen will not be able to detach at this time. So oxygen delivery will not be able to happen, wherever in the first case oxygen delivery can happen. So in the first situation, if you can write in the comment box, in the first situation the curve will shift towards the right side or the left side. So in the first situation, you can pause the video and write your answers. So in the first situation, what will happen is that affinity, it is decreasing, so, and oxygen delivery can happen in this case, right? So the curve will shift towards the left side in this case, sorry, towards the right side. Okay, so curve in this case will shift towards the right side. Okay, so that is the thing. So curve will shift toward the right side in this case. And what about the second situation where the affinity is increasing? It means we are talking about the lungs. Here the oxygen delivery will not be happening much. So here the left side shifting will be seen of this curve, right? In the first situation, what we are seeing, if the affinity is decreasing, we can see the right sided shifting. In the second situation, affinity of hemoglobin with the oxygen is more, so left side situation. In the first situation, we are talking about the tissues level. In the second situation, we are talking about the alveoli level or the lungs level, right? So this is the oxygen hemoglobin dissociation curve. This is the S-shaped curve, right? Just a revision. This is called as the flat upper part, that is the plateau region, right? And this is the steep part, steep lower part or steep region, right? I told you already, if this is the 100 partial pressure of oxygen, even if the partial pressure of oxygen will drop till 80, right, desaturation doesn't happen, it will be maintaining around 97% of oxygen, right? That is the beauty of the plateau region. But if we talk about the steep region, right, if we talk about the steep region, that is the P40 over here. If we talk about the steep region, even if it will move towards the 30, from 40 to 30, more desaturation can be seen, right? So that was about the steep region. More amount of oxygen can be given to the particular tissue, right? If the curve will be shifting towards the right side, more oxygen delivery, so binding affinity will be decreasing towards the right side of the curve, binding affinity will be increasing towards the left side of the curve, right? Now there are some factors which can decide the fate of this curve. For example, if the curve is shifting towards the right side, the affinity will be decreasing for the oxygen, which I told you earlier as well, whereas every other thing will be increasing. PCO2 will be increasing, H plus ions will be increasing, 2,3-DPG will be increasing, temperature will be increasing, because at the tissue level metabolism is high generally, right? So that is the case over here. Okay, so obviously if the hydrogen ions are increasing, the pH will be decreasing only. This we know that, right? Because pH is the negative logarithm of hydrogen ions. So in the left shift, what will be happening? Just opposite to the right shift. So affinity, binding of the oxygen with the hemoglobin will be more only, whereas other factors like partial pressure of carbon dioxide, hydrogen ions, 2,3-DPG, temperature, all of them will be decreasing. Even the HbF, okay, this will be shifting the curve towards the left side, right? So I hope there is no confusion. So finally we are in the position where we shall talk about this important effect, that is the Bohr effect. So in this O2 Hb dissociation curve, we are discussing about the Bohr effect, right? So in the Bohr effect, what it is saying, it is telling us about the shifting of the curve only, either to the left side or the right side. So the effect of CO2 and the H plus ions, these are the two very important elements over here. The effect of carbon dioxide, the hydrogen ions on the affinity of hemoglobin of oxygen is known as the Bohr effect, right? So if the CO2 and the H plus ions will be increasing, that will shift the curve towards the right side. If they will be decreasing, they will shift the curve towards the left side. So a shift of the curve to the right is physiologically advantageous at the tissue level, because we shall deliver more amount of oxygen to the tissues, obviously, right? Whereas if we talk about the rightward shift enhances the unloading of oxygen for a given PO2 in the tissue, thereby increasing the ability to release oxygen to the tissue, which we have talked just now. A leftward shift, whereas increase the affinity of hemoglobin for oxygen and lowering the ability to release oxygen to the tissues. So moreover, just remember, if your curve is this, right, if it will move towards the right side, right, you are going towards the tissue level, so you need more oxygen, so binding affinity will be lower, because I told you that more tightly you will binding to something, right, you will not be able to release it. If you are holding something loosely, it is having more chance to releasing, it is having more chance to release something. If you are holding something very tightly, it is having less likely chance to release from there, right? So if your S-shaped curve is going towards the left side, the binding affinity is increasing, that's why oxygen delivery might not be seen over there. Okay, so binding affinity will be increasing on the left side. So again, what was the Bohr effect? Bohr effect says that effect of CO2 and the hydrogen ions on the affinity of hemoglobin oxygen affinity, it is called as the Bohr effect. So moreover, in the summary, I would like to say that O2 Hb dissociation curve is a very important curve. This is the S-shaped curve having two parts. Upper part was the plateau region, lower part was the steep region, right, this curve might shift towards the right side or the left side. If it is going towards the right side, binding affinity of hemoglobin with the oxygen is decreasing. That's why it will be able to release more oxygen to the tissues. If it is going towards the left side, that it is having the higher affinity of hemoglobin with the oxygen, that is at the lungs level, so it will not be able to release the oxygen to the at that particular time, right. Then I told you what is the significance of the plateau region. Even if the partial pressure of oxygen drops, the saturation level will be maintained. What about the tissue level? We can see the steep region. In the steep region, if tissues need more oxygen, the more oxygen might be delivered without much change in the partial pressure of oxygen, right. Then further we talked about the Bohr effect. Bohr effect says that there are certain factors which will define the fate of this particular graph. So they says that the effect of carbon dioxide and the hydrogen ions on the hemoglobin oxygen binding affinity, that is called as the Bohr's effect. There are some factors which can shift the curve towards the right side. They are increase in the carbon dioxide, increase in the hydrogen ions, increase in the temperature, increase in the 2,3 ppg. And on the other side, if the curve shifts towards the left side, there are some factors such as decrease in the carbon dioxide, decrease in the hydrogen ions, decrease in the 2,3 ppg, or decrease in the temperature, or even the HPF can shift the curve towards the left side. I hope you enjoyed this particular video. If you did, please hit the like button. Do consider subscribe if you like it, and I will see you in the next one. Thank you so much.